Well, hello and welcome back. The assignment that I asked you to do yesterday was to look at lesson, if you notice we're still in lesson 13. We did the top part up here, and I wanted you to go ahead and fill in the chart here for making a new color of paint. You notice we're mixing the blue paint with the red paint. We have our variable here, B for blue and R for red. The ratio that I gave to you is for every 1 gallon of blue paint, we need 4 gallons of red paint. So the relationship you should put here is that if I take my red paint, the red paint is going to be equal to my blue paint, which is 1, times 4, because we're multiplying times 4 here. So if I know I'm multiplying times 4, most of you know that 2 times 4 is 8. So I had 8 gallons of red paint. My 8 gallons of red paint is my red paint times 4. 3 times 4. So 3 gallons of blue. I needed 12 gallons of red to make this special color of paint. So if I have 12 gallons of red, that equals my blue gallons times 4. Same thing here, 4 gallons of blue paint. In order to find out how much red paint I would need, I'd multiply times 4, which is 16. So my red paint is equal to my blue paint times 4. Last one here, 5 gallons here of red paint. If I have 5 gallons of red paint, I take that times 4. That's 20. So my red paint is equal to my blue paint times 4. So we have set up the relationship, or actually made 1, 2, 3, 4, 5 equations in order to solve this. So there's lots of questions that somebody could ask. You could come up with a question saying, well, if I have 12 gallons of red paint, how much blue paint would I need? I could use my table for that. If I would say, if I had 5 gallons of blue paint and 20 gallons of red paint, what would my total gallons be? 20 plus 5 would be 25. So there's a bunch of different kinds of questions that we could actually ask by looking at this table. Well, what I would like for us to do down here is we're going to actually write some equations with variables. And if you remember yesterday, variables are the letters that represent the colors we're using. So for example, let's say I want to know how to get my red paint. So if I had these numbers covered, how do I go from my blue paint to my red paint? Well, in order to go from my blue paint to my red paint, I multiply it times 4. So in order to find out my red paint, I took my blue paint times 4. Well, yesterday we learned that we could actually write this with a coefficient in front and say my red paint is 4 times my blue paint. So you could actually put in any number here. For example, I could say, well, what if I have 7 gallons of blue paint? How much red would I need? I'd put my 7 here, and I'd say 7 times 4 is 28. I would need 28 gallons of red. This is the equation to find out how much red paint I need if I only know how much blue paint I have. Well, what if I want to know my blue paint, which means you don't see these numbers? How would I go from my red paint back to my blue paint? What did I do to this 4 to get a 1? Well, instead of multiplying by 4, I divided. 4 divided by 4 is 1. 8 divided by 4 is 2. 12 divided by 4 is 3. So I took my red paint here and I divided it by 4. So I took my red paint and I divided it by 4. That is an equation. However, I wanted to keep it as a coefficient in front of my variable. We remember yesterday that when you divide by a 4, that actually would be considered cutting it into fourths. And so I'm taking a fourth of my red paint to get my blue paint. So once again, let's say I have over here, I know how much red paint. Let's say I know I have 40 gallons of red paint. How much blue paint would I need? Well, I would take my 40 gallons and I would divide it or cut it in fourths, which would be the answer, 10. Okay, so lots of different things that we're kind of processing and learning here. We've made some equations here with equal signs. We've had a variable and a coefficient. Go ahead and let's turn over to the next page. All right, let's look at what A says. Using the same relationship of red to blue from above, create a table that models the relationship of the three colors, blue, red, and we know that blue and red make purple total paint. Let B represent the number of gallons of blue paint. Let R represent the number of gallons of red paint. Oh, we have a new variable. T represent the total number of gallons of purple paint. Then write an equation that models the relationship between the blue paint and the total paint and answer the questions. All right, so we already know that the relationship is for every 1 blue gallon of paint, we have 4 red. What's the total gallons? 4 plus 1 is 5. So if I would do 2 gallons, 2 times 4 is 8. Total gallons, 8 plus 2 is 10. So remember, we're doing total this time. Well, what if I told you we have 3, 4, and 5 gallons of blue paint? Go ahead and see if you can fill in those missing numbers in our table for me. All right, so most of us are realizing, remember, we're multiplying by 4 to go across. So you should put 3 times 4 is 12. 12 plus 3 is 15 total gallons. 4 times 4 is 16. How many total gallons? I have 4 blue gallons and 16 red. That's 20. If I have 5 blue gallons, I have to multiply times 4. That's 20 for a total of 25. All right, now comes the challenging part. We want to write an equation, okay? We want to write an equation figuring out how to get the total. Well, since T stands for total, our equation is going to be, we want to find out what the total is equal to. How do we get the total? So if I would lay my pen right here, and I'd say, let's look at the blue paint. What do we do to the blue paint to get to the total? Look carefully and tell me, what am I multiplying blue paint times to get the total? Blue paint times to get the total. Ah, some of you are right. We took the blue times 5. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. 4 times 5 is 20. 5 times 5 is 25. So in order to get the total paint, we took our blue, which is our B, and we multiplied it times 5. But remember, we like to write our equations like this. The total equals 5B. Remember, that means multiplying. Value of the ratio of total paint to blue paint. Well, the value, if you know total paint to blue, the total paint was 5. The blue paint was 1. So my value is 5 to 1. How is the value of the ratio related to the equation? Well, the value of the ratio is used to determine the total paint value by multiplying it with the blue paint. Oops, let me move that up there. I'm sorry. All right, so the value of the ratio, 5 to 1, is used to determine the total paint value, our total paint value, by multiplying it with the blue. So we found out that we took our value here, 5 over 1, which is actually the same as 5, and we multiplied that times the blue to get our total. All right, if you need to pause the video so you can get it written down, you sure can. I'm going to go ahead and move on to the next one. It says, during a particular U.S. Air Force training exercise, the ratio of the number of men to the number of women was 6 to 1. Use the ratio table provided below to create at least 2 equations that model the relationship between the number of men and the number of women participating in this training exercise. Let's be very careful. The ratio is 6 to 1. But the word that was listed first is, we're talking men to women, men. And if you notice, it's not in that order down here. So men would be 6 and women would be 1. Go ahead and see if you can fill in the rest of my table. All right, so I have my table filled in. How did I go from women to men? What did I do each time? Well, it looks like I took the women times 6. 2 times 6 is 12, 3 times 6 is 18, 4 times 6 is 24, and 5 times 6 is 30. So in order to find the men, so the variable is m, in order to find the men, I took the women and I multiplied it times 6. Well, we know that we can actually write that problem like this. 6 times W. So in order to find the men, we took 6 times the women. Well, what if I wanted to find out how to go the opposite direction? Instead of finding the men's variable or equation, I want to find the women. How would I find out the women if I covered these up? How did we go backwards from 6 to 1, from 12 to 2, from 18 to 3? You were correct. Instead of multiplying by 6, we divided by 6. So we took the men and we divided it by 6. Now we could keep our equation like this because that is correct, but we also have learned that dividing by this number also means we are cutting it into 6. So we can take 1/6 times the men. Now if you notice the value here of this equation, the value is 6 to 1. And the value down here is 1/6. Well, it says here, if 200 women participated in the training exercise, use one of your equations to calculate the number of men who participated, which means if I took this and extended it and put the number 200 in here, how would you find this answer? Well, some of you already know you're going to take it times 6. Well, if you took 200 times 6, what would you get? You're correct. You would get 1,200. So what did we do? Well, we actually took the women. So we did this equation. In order to find out the men, which we wanted to know, we did 6 times W. So we did 6. We took, and instead of the W, we put our 200. And we did 6 times 200 to find out our men. Okay, very good. You guys are doing a great job. All right, so what I would like for you to do is I would like for you to attempt to do problem C tonight for your homework. It says Malia is on a road trip. During the first 5 minutes of Malia's trip, she sees 18 cars and 6 trucks. Assuming this ratio of cars to trucks remains constant over the duration of the trip, complete the ratio table using this comparison. Let T represent the number of trucks, T is our trucks, and C represent the number of cars. Well, you notice it says 18 to 6. That's not our first ratio. 18 cars is right down here. So we have 18 cars. So go ahead and put your 6 trucks here. see if you can fill in the rest of the table. I want to see if you can, what is the value of the ratio of the number of cars to the number of trucks. So you're going to give me cars to trucks. Okay. And then it says, what equation would model the relationship between cars and trucks? And at the end of the trip, Malia had counted 1,254 trucks. How many cars did she see? So you might want to add something like this and put this here and see if you can solve that. Okay? Right here when we're going to do an equation, I basically want you to see how can you get the cars. What would you do to the trucks to get the cars? And then do the other equation. How do you get the total? Or the trucks. How do you get the trucks? What did you do to the cars? Okay, we'll go over this tomorrow.